Now, for our case here, SMM, we use the East African version. We are not yet there for the Ugandan version. So East Africa is what we use. Now, I must also let you know, for example, there is the SMM for UK, USA, South Africa, and others. Many of these countries, even India, they have got their own SMM. But what is common is that the presentation and the description in the SMM is the same. The only variation will come in the standard materials, as we shall see. That is one. So when you are handling building works, we shall use the SMM for East Africa. Now, when it comes to civil engineering works, these ones we shall handle, we shall use the CESMM. That is the Civil Engineering Standard Method of Measurement. And we are using the UK version. So when you are given as an engineer that the project is all about, say, civil works, you know you need is the CESMM. If it is building works, then you know that you need the other, the SMM. So the comparison between the two is what I want to look at. That's the method of measurement in civil and building works. So if you are going to compare these two, how do they differ? That is where I want to highlight a few areas. One, I look at the detailing in measurement. When you look at the details in building works, these are usually for more precise, they are far more precise at the time of preparation. So when you are preparing BOQs or you are taking off for building works, these are very precise. They are short, they are very clear, articulate to the point, which is not the case when it comes to the civil engineering works. Number two, I look at the small rates. Some rates in the building works are very small as a result of small items being measured separately. As we shall see in the takeoff, that sometimes what you've measured is so small, and so the takeoff is very, very minute. The risk in pricing, this is more in pricing civil engineering than building works, because any small or slight mistake that you'll make in the civil engineering pricing, that is going to affect a great work than when it comes to building works. Then we have variations. Variations, these appear in all tenders. It is very, very hard to work out a project where there are no variations. To the starters, of course, I know I'm speaking to some diploma holders. This is not the case, and I know you'll bear with me. I'll have to move slow and to explain to my colleagues who came straight from Senior 6. Variations is that as you execute a project, there comes changes on ground or on site. Whereas the architect or the structural engineer gave you a project, you find that when you reach in reality, you need to add or to deduct a few items. That's what we call variations. So in building works, there are not much variations. Yet, in the absence of variations, building works will not be subject to remeasurements. Whereas in the civil works, if variations majorly come in, you may have to do remeasurement. Now, I'll talk about the other fifth item is the bills of quantities, which is the end point. We are doing all this work so that we end with the BOQs or bills of quantities. Building works fully describe and accurately represent the works to be executed. If this work cannot be achieved, or the articulation is not there, the works are described as provisional, or we give them a bill of approximate quantities. We shall try to reach that area. For civil engineering BOQs, now I'll use the BOQs because you now know I'm talking about bills of quantities. Many of these abbreviations, I bring them so that I don't continue using the same words. For civil engineering BOQs, a list of items giving brief, identifying descriptions, and estimated quantities of work comprised in contracts are given. Then in building contracts, specification is not a contract document. I want you to note that it is a common question we ask to give reason why. To the starters, if you've looked at architectural drawings, usually in the section, if somebody took a section, he or she will tell you the roof comprises of this. I hope you've seen that. Probably you'll say you'll have corrugated iron sheets, gauge 32, placed on 50 by 75 timber purlins, placed on 50 by 100 rafters, trusses made of this and spanning. That is what we call specifications. Now, for buildings, it is very easy to put them in the plans, and therefore specification is quite not necessary as a separate document. But when it comes to civil works or BOQs, definitely these are detailed. So the contract document will require that you have specifications as a document. It's a very big document because you have to tell us if you are talking of excavation, say, of plumbing works, what do we do, what follows. So this is why this document is very, very important. Now, I'll share something about the fixed item, that is the mixed type of works. In some larger civil engineering contracts, there are also some building works. For example, if say the project is about a large power station which we are about to put up, definitely there is no way you are going to avoid combining both civil and then also the building. So the best procedure in this case, if the contract is about a large power station, you'll have to deal with the two separately. The best procedure is to measure the main superstructure. When I talk about superstructure, I hope somebody knows and differentiate this. So you have to separate the main superstructure, the supplementary buildings, and probably the chimney as per SMM for the building works. Then the rest of the works comprising of the heavy foundation of, say, piling, the cooling towers, the roads to the project, the sewers, etc., those you measure them under the civil engineering SMM. Okay. Talking about administration, the structure of the team concerned with the construction of a civil engineering project is similar to that of building works. The structure is the same. The only difference is about the officers. In the civil engineering case, the head will be the engineer. I want you to take note of that. It is a common question that we normally ask. When it comes to civil works, the head is the engineer who is assisted by, say, a resident engineer. While for the building works, the boss now is the architect who is assisted by the clerk of works. This is why when it is a building work, the architect is always on site to check the progress, to redo the estimates if there are any variation, as I said earlier. But if it is civil works, we don't need the architect. This time we need the engineer himself, and probably that is you or the assistant. Okay. Now I'll definitely go to introduce the measurement of building works, where we are now. Sorry, I keep admitting people, so you allow me bring in those people as they come in. Okay, so the purpose of measuring is very key for you. You must know why we measure and the benefits to that. So now I will handle first the building works. The purpose of measuring building works is to establish the correct amount of work to be done. That's the purpose of this. So this involves producing accurate quantities in a comprehensive way. Technically accurate, and you must be very clear. Those two words, I underline them because they're important. It is a comprehensive work, but you must be very accurate and clear. Otherwise, you may end up giving somebody a project where I've seen, I think yesterday I saw in the media, where the architect, I think an amateur, quoted the house to be sold and was put in media, and they quoted it 2 billion. But you look at a residential of 2 billion and you wonder. So good enough on social media, you'll see so many professionals, they came out and they said, no, you are lying, this can't be. Okay. Measurement is used by various stakeholders and construction professionals to calculate the quantity of work to be done. For example, a project manager may require the gross floor area of a proposed block to establish a building budget at the initial stage of the contract. So if you are the project manager, definitely you cannot just start from scratch and say you just put up bricks. No, you are expected to produce quantities. That is why this is very important. Now, if you are the quantity surveyor, definitely you also need these quantities. You may calculate the approximate quantities of work during design. Yes, at the design stage, you produce costs. I must tell you that big contracts, we don't just produce quantities at once. You begin by bringing estimates at the initial stage so that the client is able to understand if he can fund or be able to execute the project. Now, when it comes to the final stage also, the quantity surveyor will definitely need it. Will definitely need it. The other area or the other participant who needs these quantities so, okay, sorry. Yes, I'm following this information. I'm letting you in. Now, Hilary and everyone, somebody is asking a question. I pray that we shall answer those questions later. Hilary is asking, but is building works not civil engineering? No, now you didn't get me well, but this should have been your construction technology. I said that in quantity surveying, maybe you came in late. We have building works and civil engineering works. Yes, the two differ. If you are handling, say, a residential home or a construction of a building, that one is called, it falls under the category of building works when it comes to quantity surveying. Now, if you are dealing with a project like a road work, water works or sewer, those are called civil engineering works, Mr. Hilary. But I prefer that questions will come in later. So when it comes to the contractor will present measured variations as part of a final account settlement. Now, the contractor may execute his work or her work, and at the end, you very well know, though in Uganda, we rarely do it apart from those big projects and where supervision is serious. But every project that you do, you must present as built drawings and as built quantities. So when you put up a structure, now you'll bear with me that the way I set this, it will be running 40 minutes on your group meeting, and then we'll keep rescheduling. So you just keep joining. Definitely, if it happens to go off, you must get on board. So it is about to time out, and then of course we shall have to continue in the same way. So in case you get off, please just join in the same way like you did, because we set it at 40 minutes. Now, I'll give the history about the building works. Measurement of building works is also known as quantity surveying. The earliest quantity surveying firm was in 1785 in the UK. In 1802, the Scottish quantity surveyors met and produced the first method of measurement. Now, I must also tell you that if you are taking off quantity surveying, it is a standard that somebody who's in any other destination is able to follow. You don't say, for me, this is how I do it, like we shall see. They are standards. That's why we call it standard methods of measure. So up to the middle of the 19th century, building works were measured and valued after completion of works. Imagine, you would just have to put up works, then after completing, you produce the measurement. So the need for quantity surveyors became obvious for the following reasons. Number one, building works increased in volume. So there was no way one would wait to complete the project because there is another project coming in. Okay, so now if one waited for a project to be completed, imagine. So, and secondly, the reason that I'll give, I'll show you definitely how. So once these works became so huge, the other method had to cease to be operational. Okay, now building owners became dissatisfied. They became dissatisfied with the method adopted. So it is, as I said, when it times out, definitely you log in. When it times out, because we set 40 minutes. Okay. So, okay, I said building owners. Okay, so building owners became dissatisfied with the method adopted for settling the cost of the work. And some craftsmen were not conversant with the preparation of this cost, and since they engaged the surveyors. So imagine craftsmen are normally the artisans. These, for example, the certificate holders, so they were not very conversant with preparation of these costs. So there were also problems on reconciling the amount of materials listed. Imagine for you estimate that your material value goes to $1 million, but on site, the client tells, so far I've spent 1.5 million. So now reconciliation became a problem. Then some of the craftsmen made extravagant claims for the waste of materials on site, especially if you handle the materials poorly. You have so much waste on the ground. So these all were the challenges that came up. So due to the above reasons, general contractors became established during the Industrial Revolution, and they submitted inclusive estimates covering the works of all trades. These engaged the surveyors to prepare bills of quantities on which their estimates were based. Okay. Sorry, I'm keeping admitting people as you come in. So when you see me stop somewhere, sometimes I'm admitting 1 or 2 people just getting on board. So as competitive tendering became more common, the general contractors began to combine to appoint a single surveyor who would prepare bills of quantities to which all contractors depended. So in addition to this, architects on behalf of the building owner, because I told you if it is a building works, the architect is the boss. If they are civil works, then the engineer is the boss. So regarding quantity surveying. So the architects on behalf of the building owners usually appointed a second surveyor. This one collaborated with the surveyors for the contractors in preparing the bills of quantities, which was used for tendering purposes. In later years, it became the practice to employ one surveyor only who prepared an accurate bill of quantity and measured any variation that arose during the progress of the job. So this was the origin of independent and unbiased quantity surveyors that we have today. Okay. I'll now talk about the common terms that you will come across because when we begin marathon, I may not have to get back into this. One is the SMM, which is a document which provides a uniform basis for measuring. Now I want you to quote, I said it provides a uniform basis for measuring building works, and it represents the essentials of good practice. So now let me talk much about that. Once we use the SMM for measurement, your work can be interpreted by somebody who say is in the UK, who's in the US. That's why you must depend on the standard. This one is a legal document. It is like a constitution. So I've seen some people where, like we shall see, for example, if you are dealing with walls, the SMM will tell you for all wall measurements, you present them as square meters. Now, you don't present them as cubic meters because for you want, it is easy for you. Say, for me, let me use the cubic meter. No, the SMM has clauses. The word clause is a legal term. Like if they tell you clause 1.1.2 of BS or of the Eurocode or of the laws of Uganda, the Constitution of Uganda. So this is how we also quote this. These clauses are key. So you must follow what is expected of you. So if you do, I've seen where, for example, you'll find that some works in concrete, the SMM recommends you to use cubic meters. Then some works, it will tell you to use square meters. And then there are some other works where you use the linear meter. And then in the description, that's where you state the other units. So, dear students, this is not for only examination purposes. That sometimes a student will think that this is because Engineer Sechigong wants it that way. It is not me. It is the standard. So even in the exam, even if you got the answer right, but the SMM told you to use a cubic meter, definitely you shall have gotten it wrong. Therefore, I want to encourage you to follow suit, follow what is expected of you. As I said, that the timing for this presentation, I'll be renewing it every 40 minutes. So in case you are off, definitely please relog in. We are continuing with the 40 minutes schedule. So on my time here, just a few seconds, and then we shall continue. For questions, reserve the questions, they will come at the end. Hope you are still with me.
We are with you.
You are with me. Okay, thank you. And I hope you are following.
Yes, we are following.
Okay, thank you so much. Okay, let's continue.
Sir.
Yes.
Sir.
Yes.
We also streaming you live. We have published our YouTube channel, and we want to premiere you live. And also we are recording your lecture, and we hope also you record that lecture and we premiere it on our YouTube channel for others that are not here yet.
Okay.
Yeah,
No,
I would hope we record that starting from now. We have been recording from where we began from.
Okay. You know, I've recorded.
Thank you very much.
I started a bit late. I had gone, I think, one slide or two, but I recorded.
Okay. We are premiering you live, and also we want to put the recording on our YouTube channel for others to follow back afterwards.
Okay.
All right. Thank you very much.
You're welcome. So can we continue now?
We can continue, sir.
Okay. So I've already explained about the standard methods. Now I'll talk about the quantities. Now, this is the estimated amount of labor and the materials required in the execution of the various items of work. Now, so anytime we talk about quantities, we are talking about labor and materials. So put that at the back of your head. Now, bills of quantities is the other common term. Sorry, those of you who are coming in, definitely, I keep admitting you as you come in. The BOQs is a fully described and accurate representation of the works to be executed. So BOQs consist of preliminaries. The PS and the PS, I will definitely explain the prime costs and the provisional sums and the measured works. The other common term is the taking off. Is the taking off. Sorry. So taking off. So this is the measurement of quantities in which the dimensions are scaled or read from drawings. Now, my listeners, I must tell you that there are two ways we normally do the takeoff. You either scale off, or you measure, you read the dimensions. Now, for scaling off is a bit tricky because sometimes when they print those drawings, the scales somehow do not come out accurately as the original drawing. So I want to discourage dependence on scaling. Scaling off means you get a ruler and you measure. Usually, if you are not sure of the scale, you can measure a given dimension, say where they have written 3 meters. Now, if I put my ruler and the dimension by the ruler, it is giving you 150 millimeters. That means you have to convert the 150 millimeters to equate it to the 3 meters, and then you'll get the scale that is used. That's what we mean. So sometimes if there is a missing dimension, you may have to get a scale rule or a ruler and measure that and enter it within the takeoff dimensions paper. I'll talk about the dimensions paper. So I'm saying the takeoff is the measuring of quantities in which the dimensions are either scaled or read from drawings, and they are entered in a recognized form or a specially ruled paper. This paper is called the dimensions paper. Mark my word, I'm saying in a recognized form. You don't do it the way you want. The way you do it must be recognized internationally. Talking about the working up, the other word that I shared with you, I hope you remember, I talked about, if I can revert you a bit, taking off. Now, after you've taken off, you come to this next stage we call working up. Working up comprises the squaring of dimensions. I will explain the word squaring. It comprises about squaring. Now, for example, if you enter the dimension of a length and a width, if you multiply the length and the width in this course unit, we call it squaring. You square off the dimension and you transfer the resultant length, that is the total areas or length and volumes, to what we call an abstract sheet. I'll talk about the abstract sheet later. So now, before you generate the BOQs that you are commonly well versed with, I believe, that is the BOQs you've had, where are the bills of quantities for this project, where are the BOQs for this project. Now, that process begins with the process that we've begun today. We begin by taking off. Then what you've taken off is worked up. Then after working up, what we enter into the abstract sheets, we convert those dimensions and we push them to generate what we call the bills of quantities. I'll talk about the preambles. Preambles are able clauses inserted at the head of each work section. Now, if you went into a bill, the first writings that you read, these ones will guide somebody, the estimator who's handling the BOQ, what is done or what is expected, the details of the billing item measured. So they normally write them as say an introduction statement. So these are able clauses inserted at the head of each work section, covering matters related or relating to the specific work section that should be brought to the attention of the estimator. Now, preliminaries are items in the BOQs entered for purposes of setting out all general liabilities and obligations of the contractor. Now, in the BOQ, normally the first pages, you'll see what is expected of the contract. Those, they write the title preliminaries. They are required to be executed at the pre-commencement or during the progress or after the actual works. For example, if you are going to bring a container on site, it must be quoted under the preliminaries as the engineer's office. Say you are going to tap water for the site, all those will come in under the preliminaries. We shall see some of these works. And I want also to encourage you, now that you've begun this course unit, please begin to visit. If you are in an office or you've been looking at some bills of quantities and you didn't understand them, now all that I'm explaining, please try to visualize. If you have a copy around you, that is also better. There is what we call the main contract preliminaries under preliminaries. Now, the main contract preliminaries are items that cannot be allocated to a specific element or a sub-element or a component. For example, if you are talking about main contractors' cost associated with management and staff. This one cannot be allocated to a specific element. So we bring it as a main contract preliminary. Now, the others say is site establishment, temporary services. Sometimes you may bring water temporarily on site, but it's not permanent water. Please, this is white, so we look at it that way. Then security, all these fall under the main contract preliminaries. The other common term is about the contractor. The contractor is a person or corporate body, because for example, if you are talking about a body like a ROCO construction, this is a corporate body, but it is, we can say our contractor is ROCO. Our contractor is, say, National Housing. This is what I mean here as corporate body. Now, a contractor is a person or corporate body whose bid to carry out the works has been accepted by the employer and engaged to undertake the works. So once you are accepted as an employer, then we can define you as a contractor. Now, who is the employer? The employer or the client is the party who employs, who gives the assignment, who gives the project to the contractor to carry out the works. I'm sorry I used the same word employee, but never use it. Like it's saying, who is an engineer? And then it's an engineer is an engineer. No. Main contractor is the other term, or prime contractor. The main contractor is the person responsible for the total construction and completion of the project. Is the one responsible to complete and hand over the project. Somewhere I'll talk about the contract documents, and I'll show you there is a term that is common, obligation. Obligation means what is expected of you, what you must do, boss. So if you are a contractor, what is expected of you is your obligation. Now, each of these parties have got obligations. The client has an obligation to pay. The contractor has an obligation to deliver. That's why we use the word obligation. The other term is about the subcontractor. The subcontractor is the contractor employed, or is the person employed by the main contractor. Okay. His purpose is to undertake specific work within the project. Quote that, he does specific work. That's why he's a subcontractor. For example, it may be to install electrical works. So he's doing specific works. Now, sometimes the subcontractor is referred to as a specialist contractor, is referred to as a works contractor, is referred to as a trade contractor, is referred to as a work package contractor, is referred to as the labor only contractor. So he has many terms. If a question came in exam and they have changed, they say define a works contractor. It is another way of telling you define a subcontractor. We have nominated subcontractor. Now, when we talk about a nominated subcontractor, this one is chosen by the architect. If the project is headed by the architect, because sometimes if the client is not solely on ground, he may appoint a representative, and that is the architect. So if the architect appoints a subcontractor, that is a nominated subcontractor. But still, he may be appointed by the client directly. or the engineer or in charge of that project he may appoint. So a nominated subcontractor is either appointed by the architect, the client, or engineer to carry out certain aspects of the work. And the expenses thereof are covered in the PS and the PC, inclusive of bills of quantities. The prime costs and provisional sums, that's the PC and the PS. I'm going to explain more about them in the following slides. Okay, I'll move to the work package contractor. This one is a specialist contractor who undertakes particular identifiable aspects of work within the project. For example, you bring somebody to do cladding. I hope you people understand cladding. These are common in Kampala, those wall finishes, we call them cladding. You appoint somebody to do mechanical services, say lift works is going to do to install the lift. This one is called a work package contractor. He can be directly employed by the employer, or he may be employed by the contractor. Then we have the overheads and profits. Overheads and profits, well, I have to check to see if my people are still there. Are you there?
We are there.
Yes.
Yes, sir, we are there.
Okay. Somebody is asking to share the screen. Does it mean you are not seeing the screen?
We are seeing the screen.
The screen is there. I thought so. Yeah, thank you so much.
Yeah.
So I'll continue.
The main issue is the people who are tapping the part of the screen that shows your face to be the main screen, and then the screen that's showing the slides is the minimized screen.
Okay, thank you for that guidance. Okay, so let me continue. Okay, so I'll talk about the overheads. Okay, I'll talk about the overheads and profits. Now, in any project, dear students, engineering is a business, and let me repeat it again. We are all surviving in this engineering business. Mark my word, it is a business. Any business, you must make profits. I hope that is very clear. Now, there are people who think that engineering is passing time. No, it is a business. Myself, I'm surviving in engineering because it is a business, like somebody can go to Chikubo. So then overheads and profits means the contractor's costs associated with the head office administration, proportioned to each contract. So each contract will have different costs to maintain. That's why if a project today, now in this COVID period, if the project is say in Igulu and you are a resident of Kampala, definitely it will become a very expensive project because you have to cater how you reach to Gulu and so on and so forth. That's why when it comes to bills, we must cater for overheads and your profits. Then here we add the main contractor's return on capital. So the profits will be catering for the returns on the capital you invested. If you say you are handling a project, sometimes as a contractor, you may be the one injecting in all the monies to raise the project, and then you have agreed with the client that she or he will pay you after. So if that is the case, that means you have to put a small fee somewhere for interest, for profit, because Munange, money makes money. If I was able to put, say, 300 millions in to put up a kitchen for you, definitely I will have to put in profits, a percentage. Kubanga, this is money. Normally what we do as contractors, I must tell you, it is rare for a contractor to have all the monies available. So myself, I also have to run to the bank. I run to the bank to borrow money. When I borrow money, the bank will be demanding money from me, isn't it? So money makes money. This is why when it comes to profits, we put in these interests so that I don't return all the money to the bank. I also make some kalitoka money, as the saying goes. The director's adjustment. This one means a reduction or addition to the tender price and is derived by the contractor's estimating team. Usually you have a team to find the director's adjustment. Provisional sums, which I will abbreviate as a PS in many of the works that I will do, and even in the BOQs. Of course, I will explain to you that we rarely write some of these words in full. When I write PS, any quantity surveyor all over the world will know I'm talking about provisional sums, not permanent secretary. Now, provisional sums are sums for works which cannot be measured accurately during the takeoff. So it is a sum provided for works or for costs which cannot be entirely foreseen, defined, or detailed at the time of tendering documents. At the time the tendering documents are issued. For example, talk about testing materials. You take materials for testing, that implies that any test that is carried out, those monies, you don't know how many tests you carry out. You know there are sites where you prepare cubes to take to the lab. Let me give a scenario. Somebody who prepared cubes, myself, I'm an example. We had cubes prepared that were supposed to be delivered to the lab. And you know, you prepare them, keep them at the site for some time, and then you deliver them at the lab for the first test, say the first 7 days, and then the other day. So now we had prepared, lockdown came in, you see, calling the lab where we are supposed to take the materials. They are also still waiting for permission, blah, blah. Now, such cubes, we are wasted. These are unforeseen challenges. Now, the works have to continue. And I have to prove that these works are as per the engineers, the structural engineers' recommendation. So much as the cubes were not submitted, we have other means, we have other tests we can carry out on those particular elements so that we are in line with the works. So that's why I'm saying that because these are sums for works we cannot be measured accurately. Now the other ones we are done, remember the cubes had cement in them, they had the labor in them, they had the sand in them, but they are wasted. And now we have to incur more costs for a lab, for that lab to come on ground and do other tests. So that's why when you are doing tests, you must cater for this. So they are entirely, they cannot be entirely foreseen, they cannot be defined or detailed at the time of tendering documents are issued. The other work could be progress photographs. You know, any site, you have a photographer to keep those records. And then, of course, the contingencies. The other term is about defined provisional sums. Sums provided for work which is not completely designed, but for which the following information shall be provided. They have not designed this kind of work, but you have to quote for it. What they do, they shall provide you with the following information. The nature and the construction of the work, a statement of how and where the work is fixed to the building, a quantity or quantities that indicate the scope and extent of work, any specific limitations, and the like. So that will appear in the defined provisional sums. Then we have what we call the undefined provisional sum. Sums provided for work that is not completely designed, but for which the information required for defined PS cannot be provided. Then we have provisional item. This is an item of work identified as provisional in the contract and is to be carried out by the contractor if instructed to do so by the architect. Okay. I'll continue to the provisional quantity. When we talk about the provisional quantity, it means a quantity which cannot be accurately determined. That's the provisional quantity. Remember, I talked about provisional sum. This is now a quantity. And I hope by now, these two words are getting in, they're sticking into your head. Talking about the quantity and the sum. So don't confuse the two. So this means a quantity which cannot be accurately determined. For example, an estimate of the quantity, if you just made an estimate. To be carried out by the contractor if instructed to do so by the architect. So this one, the architect now instructs you to do so. A prime cost sum is cost for works provided by nominated subcontractors. That's the cost for works provided by nominated subcontractors. For example, electrical installations. Now, when you talk of electrical installations, you get nominated subcontractors say, now our brothers, the electrical engineers, will come into play. And I hope you people know that in any project, you'll have the architect, you'll have the consulting engineer, you'll have the M&E. You normally see M&E. M&E is mechanical and electrical. That implies that somebody is doing the mechanical work on the project. The mechanical works, we call things like a plumbing. They are categorized within this category. And then the electrical. So you nominate a subcontractor to do that work. Prime cost item is an allowance in the contract for the supply of necessary items not yet finally selected. For example, you may be looking at door furniture. So when you are estimating, you cannot say, for me, I estimated what I saw or what was there. No, you must estimate even for such items, you allow for them. You allow for them, though they are not yet there. And then we have the fixed charge. This is for work, the cost of which is to be considered independent of duration. It is independent of duration. It is a fixed charge. And then I will talk about variations that I shared with you earlier. Variations are alterations or modifications of the design. They may also affect the quality or quantity of work as shown upon the contracted drawing. You have a drawing, an architectural drawing. As you begin to construct on site, the client comes in and tells you, literally, I didn't know that my architect did not include a prayer room. Okay. probably he comes and tells you, you did. So if this is the case, variations or alterations or modifications are done on site. So if the engineer does them on site, you must include them. So this is why this clause is also very important. And I'm saying there are alterations or modifications of the design, quality or quantity of works as shown upon the contract drawings and described by or referred to in the bills. It includes additions, omissions, or substitutions of any work or the alteration of the type of standard or any material. You may even change the materials. So once they are changed, definitely they must be costed. Now you'll get a common term, ditto or do. This means once you see that term ditto, do, we are saying that which has been said before or above. You may not need to repeat it. That's why we write the small word ditto or do. Extra over. Additional sum of money allowed for items of work normally used where the work has become slightly different from that originally measured. For example, once you are measuring pipe work, valves, bends, and junctions to drain pipes, those will be categorized under extra over. You will define the pipe work length, and then you report the extra over item, the bends. Extra over items, when measuring certain items of work, they are described as being extra over another item which has been previously measured. This is what I've said. So the estimator will price for the extra or additional cost involved in the second item as compared to the first one. So in this case, definitely the pipe will, we assume it is not affected, it is not cut in any way. It is a continuous pipe, and then all the other bends, we quote them as additions. Deemed to be included items. In SMM, the expression indicates that this particular work is the billed item without the need for specific mention. For example, much as we are billing these items, rough and fair cuttings in brickwork and blockwork, we don't mention them. We just say, construct the brick wall in, say, 230 millimeter thick, and we quote the square meter. But we don't have to mention rough and fair cutting within. So those are deemed to be included items. But when we are estimating, when it comes to rate building, when it comes to fourth year, we shall mention these. We have to quote for them, definitely, to include them within the rate. Credit means a refund offered by the contractor to the employer in return for the benefit of taking ownership of materials, goods, items, mechanical, electrical plant. It is arising from demolition of strip out works. So when there is any demolition work on a site, you refund, because you may demolish and say you move away. You say, I've demolished this in Ayate. I want to go with this sealage. After all, the client doesn't want it, so we do a credit. Then we have day work. Day work means the method of valuing work on the basis of time spent by the contractor's work people. So this one, we value work on basis of time. It is on the basis of time. So every work, we value it on the basis of time. So if you spend just half a day, then we shall use the day work to find out how much you earn. The same applies to the plant employed. Raking cutting, the unfair cutting usually to brickwork in walls and roof covering materials at the hip and valley. This one will come in when we are building, say, the final rate. The form of tender is a document used to record the main contractor's price. Now, you've heard where they say they are going to sign the contract. Now, the contract, as I'll show you, will carry a number of documents. But the key document within the contract that you want to sign with the client is the form of tender. And the form of tender is a document where we record the main contractor's price for completing the project. And you will normally term that price as the tender price. If the employer accepts it, it becomes the tender price. And I mean, it will become the contract sum once you have agreed. So the first document within the many documents in a contract is the form of tender. Of course, I'll show this with time. Then we have the pre-tender estimate. This means a cost estimate prepared immediately before calling tenders for construction. It's called a pre-tender estimate. Now you see it bears the term estimate. The client may request you that before I produce this, kindly please, Ronald, engineer Ronald, can you generate for me the cost estimate so that I prepare myself? That is called a pre-tender estimate. And he does it before calling tenderers, before people come to submit their bids. We have the post-tender, estimate. It means the cost estimate carried out after evaluation of tenders to corroborate the funds required by the employer to complete the project. So after evaluation, now what I mean by evaluation, people submit their bids, and then of course, still before any project commences, the client will ask you to compare. Evaluation comes in after we compare these tenderers. And then we choose the best bidder by the employer. So if the bidder submitted his rates, okay? Because before we admit all these rates, we shall have at this stage considered the omissions that were made. If there were any mistakes within the documentation, we shall have known them. So the post-tender estimate means the cost estimate carried out after evaluation of the tenders. So you say, okay, this guy quoted this, but the way I see it, my engineer or my architect or my quantity surveyor has come up with this. And this is what we go by. Okay, that moves me to the procedures that we follow when it comes to measurement. But of course, I must ask if you people are still with me.
Yes, sir, we are still with you.
You are with me. Thank you. Okay.
Sir, we are with you.
Okay, thank you.
We are together.
Okay, let's continue. Now, that moves me to the measurement procedure. Some of the essential factors that should be considered include the following. Okay. Okay, so some of the essential factors that should be considered include: one, you must examine the drawing carefully to become familiar with the work and to identify any parts where information is lacking. Now, you engineers, you very well know when you are reading, say structural drawings come from architectural drawings. But the sets of drawings that are given to you when it comes to generating BOQs, at least on a serious project, they will give you the architectural drawings, a set of architectural drawings done by the architect. They will give you a set of structural drawings if it is a storage building done by the structural engineer. They will give you a set of electrical drawings, and they will give you a set of mechanical drawings. Mechanical drawings will definitely show you the layout of the waterworks and the sewer works. The electrical drawings will show you the arrangements of electrical installation. So that is how the full set of drawings that will accompany the form of tender that I earlier told you about and the specifications. So you can see all these are now coming up as tender documents. Now, your task is to first study if there is any lacking information in these drawings. For example, they may have forgotten a certain foundation pad. They did not give you the details. Or they may have forgotten to give the lift details. Or they may have forgotten to tell you the reinforcement detail for a certain slab. That is where you must examine. Don't rush to take off, first examine. Some of them you'll be able to fill in the information. Sometimes, even as you examine, you may discover that the guy made a mistake. He wrote H12 for a certain bar mark, yet other bar marks within the same column are H16. So you must make that correction, because he gives you a section, say at a column. Between the ground floor and first floor, he states that they are 4 H16. Then he comes to between first floor and second floor, the guy writes 4 H12. Definitely, that will now be common sense. You will know. Looking at again between the third level and the fourth level, he has again written 4 H16. So how did the 12 come in? It was a mistake. There is no need for alarm. You just cancel the 12 and write there 16. So make sure you first correct all mistakes before you go to the takeoff. Number 2, interpret carefully. Interpret carefully and apply in a sound and logical way of SMM. I'm going to show you the logical way. The SMM has given us a pattern that we must follow, and including the wording, how you present the figures. That is the next I'll be sharing with you. Then ensure a high standard of accuracy in dimensions. Now, normally we record allowing 2 decimal places. Please ensure a standard of accuracy. There is a tendency for some estimators. You read the figure, say 2.1001. Then you say, there, let me summarize it to 3. At the takeoff stage, every time you keep summarizing, you are increasing errors. So these errors are going to accumulate and accumulate and accumulate. And at the end of the day, you may even cause problem for your company to lose a job because you've generated figures that are not competitive enough. Okay. The other one, make a full use of subheadings throughout the dimensions to facilitate identification and waste to preliminary calculations. Now, I'm going to show you that when you are calculating, we normally write at the top right corner, we generate the waste. You calculate, you say, what was this unit? It is the length. So you make a small heading of it. If it is a slab, make it, just write slab. All descriptions should be adequate concise, and written in a logical and easily understood format following the sequence in SMM. I don't need to explain that. Then you must adopt a logical sequence of items so that each one follows the preceding one in a natural progression. What I mean here, your presentation must be logic. Don't present foundation, then bill number 2 is the roof, then bill number 3 slab, bill number 4 is a column. No, it is logic. And the SMM states where you start. We normally begin with the foundation. And even in the foundation, what do you start with? Say you start with this foundation pads, then we come to the strip foundation, then we shall come to, say, grinding, and so on and so forth. It should be a sequence. Let it be a sequence. Then adopt a logical, seek to achieve a good standard of presentation. This I'm going to show you. The SMM gives rules for that. What are the general rules? These ones you must, I told you we are in law now. Quantity surveying is about legal. We follow laws. Everything is about the law. You don't wake up and say, for us in Kanabulemu, this is how we do it. You don't wake up and say, according to Mama Nabanja, no. Neither is it political that according to NRM. No, this is a standard rule that everybody should avoid geopolitics when it comes to SMM. It is a legal document. And as you see, when you look at that, I'm requesting every one of you begin to look at the bills of quantities. Look at the way they state the clauses. They say according to clause this states this. These are legal terms in engineering. Rule number 1, bills of quantities shall fully describe and accurately represent the works to be executed. So those works whose extent cannot be determined accurately should be described as provisional. I already talked about that. So the BOQ should fully describe and be accurate. That I've already labored. Works, that's rule 2. Works are to be measured in net as fixed in position to the nearest 10 millimeter. To the nearest 10 millimeter. So we keep rounding off based on the 10 millimeter figure. Openings under the measured area shall be deducted. For example, when we are carrying out the wall, we measure the entire wall and then we deduct the windows and doors later. That's what we mean here. Even the ceiling, even if there is an opening there, you first measure it as a unit. The order of stating dimensions in descriptions, not this, shall be consistent and in the sequence of length, width, and height. That's what we follow. We follow the mathematical approach. Length, width, height. Length, width, height. That sequence is followed, not the other way around. Build items are generally deemed to include. I've put that word is one statement. Build items are generally deemed to include. What do I mean here? That without the need for specific mention. So all build items are deemed to be included. And when we are presenting them here, we are talking about labor, materials, say labor, material unloading, and so forth. They are all deemed to include. Okay. Rule 6 is works underwater shall be so described, starting whether canal, so water canal, whether it is a river or a sea. So if you are dealing with works underwater, say you are constructing a bridge and the foundation is supposed to be under the water, it shall be described, stating whether the water you are dealing with is sea. We are trying to avoid lies. Somebody can tell you, I was busy working under Lake Victoria. So we need to know how really accurately you did this work. But we've done works, say you are putting up a jetty for landings. I hope people understand jetties, a jetty for ships and so forth in water. You tell us the kind of waters you were dealing with and the levels of high and low. And lastly is work in compressed air shall be described also. So that one now moves me further again to talk about, to introduce general principles and the general principles of taking off the dimensions paper. Sorry, I keep checking on you if you are there. Hello there. Yes, are you still with me?
Yes, sir, we are there.
Okay.
Yeah,
We are still with you.
we're with you.
Okay.
Clear, sir.
We are there.
Okay.
Yes, sir, we get you.
Okay. Okay. Now, let's go to the dimensions paper. Now, if you are seeing that screen, the paper is divided. We get normally A4 paper and we divide it into two. The first half, that's why I've numbered. If you can recognize that sample, I've numbered 1, 2, 3, 4, 1, 2, 3, 4. So we begin on the left, and I'm going to give an example how we enter these figures. But before that, I have to describe the paper. So the measured items, that is those you've scaled off or you've taken from the drawings, they are entered on a special paper known as a dimension paper. This one is split into two, identically ruled, consisting of 4 columns. By the way, always get your paper and divide it into halfway, okay? Considering if you have the margin on the left, between the margin and the edge of the writing, you always make sure you divide it into 2. Now, number 1, where you see number 1, that column, it is a whole column, it will go down from top to bottom. We call it the time-using column. The time-using column. This one is where multiplying figures are entered. For example, if you have an item, you don't need to say you have entered the, look at a school. It has classes, P1, P2, P3. You went, you measured P1, it is 8 meters by 9 meters. You enter 8 by 9 in column 2 now. Column 2 is the dimensions column. The dimensions you measured, you bring them there. Here you entered 8, did I say 8 by 9? Yes, 8 meters. You remember we said you take length by width. So it is 9 meters and to 2 decimal places, 9.00. Below it you enter 8.00. Then you go to the next class, it has the same measurement. What we do, I'm going to show you how you enter that you now have two classes. You don't need to enter again into the dimensions column. You just put, we enter that figure in the dimension, in the time using column, and somebody who will be working up this work, usually I must also quote this. If you are the one taking off, normally we don't advise you to be the one again squaring, because you may forget errors. There is normally another team that will do the squaring. So I've mentioned now two of these, the dimensions column in which the actual dimensions are scaled or taken directly from the drawing. And then we have the squaring column, the length, areas of volumes obtained. So when you multiply those figures, you enter them in the squaring column. And then lastly, we have the descriptions column, in which the description of each item is entered. Now, when you talk about, let me also explain about the description column. At the right-hand side of this column, at the top, I hope you can see an example. Let me use that example you see below. Okay, because I want to hear you. I will allow you to respond at my question. Do you see the dimensions example I've given? Yes?
Yes.
Now let me go with you through it. Yeah, please you reduce your volume because I want us to do this example together. Now, somebody went, okay? Oh. I ask you to mute yourself so that you first listen to me. Okay. Fine. Since you are following, you'll ask questions where I do not have known. Now, do you see those tiny, the top first figures of 3.00, 1.50, 0.50? Now, that is called the rough work corner or the west corner. Now, before you enter your figures, though I began by numbering 1, 2, 3, 4, but still the works will begin surprisingly with the description column. Now, I wanted to generate, say, a total there. So I measured the first unit was 3 meters. Okay. Then as I continued, I measured another length of, now this was the horizontal DPC. So I measured the first length, it was 3 meters. I realized that when I turn a corner, it is measuring 1.5 meters. So I write it below 3. Then I discovered there was another addition of 0.5 meters. So you do it in the rough work to avoid crowding the dimensions column. So I add 3 plus 1.5 plus 0.5, and I get a total of 5 meters. Remember, our standard unit is always the meter, not feet. Feet is a site term. When they tell you in feet, convert it into a meter. So I now get my 5 meters. I enter it in the dimensions column. That is number 2. You can see 5.00, and I underline. And if you don't underline, it means the figures that you put below 5 meters, they are also part of this. And in this case, they are either added, they are either added or multiplied. So anytime you enter a figure, say like in this case, this was a linear figure. 5.5 is a linear figure. If I wanted it to be square, then that means I would put another figure below and then underline the second figure. So that is what it means. So this time, because in standards, we measure DPC as a linear item. Now, look at column 1, the time using column, how I've entered it. I used 3 with that computer mark, which you know very well. That 3 slash and then 5 means multiply 3 by 5. That's what it means. So in the end, it implies 3 times 5. I'll enter the final figure in column 3 as 15. So that is how you are going to do much of the works. So I went to the site, measured the units, brought them here. I realized, yes, 1 unit was 5. The others are repetitive. So I multiplied them by 3 and the total length is 15. So you enter it here as 15. Of course, when it comes for academics, we normally avoid column 3. We avoid the column 3. We leave it to those who will do the final works. For you, you do column 1 and column 2 in the academics. But if you are employed somewhere, your boss may require you to do all this. Then, the description there is important. What were we doing? What is the 15 meters? So the 15 meters, somebody will read here. It is now not, how I've written it is not because I was saving space for myself. In SMM, we deal with abbreviations as much as possible. And I will give a few of them, and for you, you look for the rest. And I advise you to look to practice using. So now this is in full horizontal damp proof course, 110 meters wide of a single layer of Hessian base bituminous felt to British standard 743 reference A. It is lapped 100 at joints. Every joint, we are lapping it over the other. Now, this lap is important because it means there is 100 millimeters. If I don't put any point, that means those 100 millimeters, it is extra over. You remember I talked about extra over at every joint. And it is measured in net. That bracket means measured in net. And it is bedded in cement mortar 1. No, it is not 1 point, it is 1, 2. It should have been a column 1 to 3. That is all. So now somebody who's going to build this item will be interested in looking at the description and the other items. Now I will move on. How do we enter? How do we enter dimensions? 1, order of dimensions. A constant order of entering dimensions is maintained throughout. That is length, breadth, or width, depth, and height. This I've already told you. For example, look at that dimension paper below. Remember, whenever you underline, I told you when you underline, every time you are done with the units, you underline. For example, this is concrete item, which in the SMM, concrete item in this case is measured in cubic meters. Although somewhere you'll see where it is measured in linear and also as square. But now I'm looking at the one measured in cubic meters. Say concrete, now this one means the concrete length we are measuring is 10 meters long. It is 690 millimeters wide and 230 millimeters deep. So we begin with the length, 10.00. We convert all these millimeters. By the way, not this. I've seen people in examination entering figures because the examiner tricked you and gave, say, I can give the 10 meters 10,000 millimeters. Then the student also enters it as 10,000. We don't put units when we are entering these figures. The point is enough to say to the two decimal places that these are 10 meters and 0.69, those are meters, 0.23, those are meters. Please, and then you describe. The description is concrete, grade 20. In foundations, that should be foundations, not funds. So that is where you stop. So this is a full item now. I know the foundation I'm dealing with is about that. Now, come to spacing of items. Ample space is left between all items on the dimensions sheet so that it is possible to enable an item which may have been omitted when the dimensions were first taken off to be subsequently inserted without cramping. Now, if you keep, my dear friend, if you keep just entering, you are doing us a disservice. Always make sure that as you enter these dimensions, you leave some space where it is due. Where it is not due, it is okay. For example, if there was another item about the example I gave you of the foundation, I will just leave space, and this other unity, the second measurement of the foundation, is 4 meters. But because it is a foundation, the length is only the one that is changing, but the width and the depth are the same. Now, look at the waist. The right-hand side of the description column, I said this area is used for preliminary calculations, explanatory notes, and so forth. That you saw how I generated the builder. Time using. If there were 5 items, okay? If there were 5 items, then that means that would be multiplying these 5 items. Look at the concrete grade, the foundation that I gave you. If there were 5 of them, like I did the first time, I will enter my 5 as I did for the other 3, you remember. Now, if we find that these 5 foundations, there are again more that had forgotten. There were 9, but me had quoted 5. And then maybe a colleague tells me, they are 9. They are 9. Or he wrote to you, sent you an SMS, and for you, you saw the 9 as 5. Because there are some people who write like doctors. Now, when doctors write their medicine, you may think they are at the moon. But I mean, you read the 9 like a 5. Then the guy tells you, no, there were 9. So you don't need to cancel, although I'll show you how we cancel. But what we do, we add the 4, the other 4, by a process we call dotting on. So we just write 4, we put a full stop. It may not be clear, but I hope it is. So the other 5, when I dot on 4 dot, that means that again, you add the 4 to the 5. So that is, if you multiply that figure, 10 meters times 0.6.3 times 9, you should be able to get 7.94. You can check. Okay. So I continue. Grouping of dimensions. Sorry, some people are just getting on when we are about to end the lecture. Grouping of dimensions. Where same dimension applies to more than one item. Okay. Now, you don't have to write the same description more and more and more. What we do, we segregate each of the separate description by an and. For example, let me describe that. It says site clearance. Now, when you look at the site clearance, by removing up bushes, shrubs, and the like, say is beginning a project. The site clearance item is 100 by 50 meters. Maybe that is the site. But you realize you have to remove vegetation, what you've cleared. You don't need again to write 100 meters by 50. No, you just put and. We put that and. Then you add excavation. Now that is the abbreviation means reads excavate oversight to remove vegetable soil, average 150 millimeters deep, and wheel and deposit on site average 20 meters away. So average distance, whatever you remove, will be wheeled away by wheelbarrow and you deposit it somewhere. I told you that in this work, we use abbreviations much of the time. So where more than one set of dimensions, like we've done, relate the same description, then we have to use a bracket. The bracket, you draw a straight line, top from the first description up to past bottom. Now I must tell you, usually if you looked at the first example, if I take you back where I made the total, okay, the total was 7.94. We write the total in line with the last dimension. It is not a mistake. So that's why the 7.94 comes in line with the 0.23. Did you get that? The total doesn't go in the other column. It comes this way, but in line. Now, assuming there were more totals done of this, again, their total will be below that. That is why the bracket that you draw should pass that dimension by at least another figure, so that if you total, the total is also enclosed within the bracket. Okay. Abbreviations. When we come to abbreviations, I've told you we've been using many of them. These are used in the description space in order to save space and time. But also, you don't use your concocted abbreviations, or those ones you use when you're writing your love letters. No, these ones are standard. Even those abbreviations you use with your emoji, they don't apply here. So I don't expect you to draw a smiling face to mean that the dimension was right, so you are smiling. Your emoji doesn't work here. Neither should you use those funny terms, kawa, hi, blah, blah. Those don't work here. They are standards, because I told you these standards are legal. Somebody, for example, when I write conch with a full stop, somebody will notice concrete. When I write A, full stop B, or A dot B means as before. When I write A dot B dot D means as before described. When I write N dot E means not exceeding. When I write BLDG means building. When I write B dot S means British standard. When I write B and J, it means bed and joint, and so on and so forth. There are so many. You can look for them. Now, I'll go to deductions. After you measure an item of construction, it is sometimes necessary to deduct for voids or openings. I said that. So when measuring areas of excavation, concrete oversight, block work, the best practice is to measure the full area. You measure it full and subsequently adjust for any voids or any opening. That is what it means. For example, look at this example. We excavated the oversight to remove vegetation or vegetable soil. Average depth was 150 millimeters deep. Now mark the full stop and the commas. We normally put those full stops and the commas. And wheeled and deposited average 100 meters away. Okay, so now, what was the excavation? The excavation was the total of 21.3 meters by 20, that is the first area. So because you put, you underlined the last figure, so the one who is, to whom you've sent this takeoff will multiply 21.3 by 20 and enter the figure in the respective column, as I said, column number 3. And then he will again multiply the 5 by 4.5 and enter it again in column 3. Now, he will not underline those totals. The first total will not be underlined, but he will underline the last total. And then he will add the value that he got from 21.3 times 20.3. He will add the value of 5 times 4.5, and then he will give a total below. Now, he will come again below and multiply the 2 meters by 2 meters, and he will recall, that is, they have written, he wrote deduct dito. That means that the total you got above, you must subtract this value. But I didn't want to write all these words: excavate, oversight, to remove vegetables. So dito means that the description here is the one above. I hope we are together. Very interesting. So once you understand some of these tactics, you'll enjoy the subject. And as I told you, to those who are new, who have just joined, one of the areas where you'll never think of not making money is this area. So if you can master this area where people are in the lockdown, some of us have been working because the booming industry is, the building industry is going on. They might not employ you as a structural engineer or as what, but they may admit you or give you this project for quantifying, because every stage must be quantified. So quantity surveyors, those who have the knowledge now, are busy. You work at home, generate quantities, send it to whoever it may concern. Now, let me talk about measurement of irregular objects. Now, when we talk about irregular objects, okay, while I was checking how much time I have to be done with this. Okay, let me just wind up this entire cut. It has a few areas remaining. And then please, I think I'll give you time to ask questions because there is some time. Now, it is often necessary to measure the area of triangles, because these days you'll appreciate our architects. We no longer have those bars, those rectangles, even churches. Actually, for me, I don't entertain those rectangles. But one thing you'll discover is that we've now moved into appreciable figures. You appreciate the figures it is presented. Now, triangles, circles, circumferences of circles and volumes of cylinders. Yes, we can also measure them and enter them, but how do you enter them? So I've given some of them here, 4 of them. If you are entering an area of a triangle, you know the area of a triangle is a half base times the height. That is how we enter it here. Area of a triangle with a base of 4 meters and the height of 3 meters. The area is a half times base times height. So we shall begin with the base. You first enter the base as 4 meters in our column 2, and then 3 meters to represent the height. Then the half is multiplied in column 1, as we've been doing. So somebody will know what you are doing. When it comes to area of a circle, the circle area is pi r squared, or it may be pi d squared over 4. But if it is given in terms of radius, always know one thing, write the formula first. So the radius in this case is 2 meters, So the way we square in this area, we use the time using. So you write 2, 2, then you put the pi as 22/7. Or still it is acceptable, you can write pi stroke 2, 2. We shall know what you are saying. If it is a circumference of a semicircle with a 2-meter radius, circumference of a semicircle, the circumference of a circle is normally pi r, isn't it? Yes, that's it. Or it can be pi d. But if it is pi r, you are taking radius. So you enter the radius, multiply by pi, multiply by 2. But I said it is a semicircle, so you multiply by a half. If it is a volume of a cylinder, the cylinder is 1 meter diameter and 3 meters high. That means you look at the area of a cylinder times the height of a cylinder. What is the area of a cylinder? Of course, it will be pi r squared h. So the r will be the ½ meter. Then the h is, say, 3 meters. Okay. Yeah, I said it is 1 diameter. So we prefer using the radius. That's why I'm using 0.5. Then you multiply by pi. Okay. Now, alterations to dimensions. This is common. You can't be accurate. It is at times necessary to substitute amended dimensions in place of those which have already been entered in the dimensions paper. If it is necessary to amend figures, never kukulukunya, never go and use a rubber. No, it is better to cross out the original figure and neatly write the new figure above them. How do we do it? Where it is required to omit dimensions which have previously been recorded, you write the word nil. You write the word nil. For example, I had entered my figure to excavate for strip foundation, not exceeding 1.5 meters deep. By the way, this description follows the laws that I will show you later. We normally describe in phases: not exceeding, exceeding, not exceeding, exceeding. And then R, F, and R return fill and ram. So that means after you excavate 23 meters by 0.75 by 0.8, again, we return the fill. This I will show you how we calculate a number. We assume what you've excavated in the first case, you return it all. And then you keep deducting. So when you concrete, you say concrete, blah, 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 and deduct return fill and ram. So that space occupied by the concrete will again be deducted. So the person who's going to do the abstracting knows how to deduct those figures. So assuming I'd entered 8.2, 0.7, and then I realized that, it shouldn't be there. So what happens, you cross on top, above, and below, and then in between you write the word nil with the arrows, an arrow on top up to the other line, arrow to the bottom of that line. So even if it is an exam and I see that, that means you are telling me that this one overlook it, don't consider it. That's what it means. Now, sorry, I'd gone far. I thought I'd reached this far. I hope I'm still with you, definitely. Okay, I'm on 3.6. Okay, figured dimensions. When you are taking off, it is desirable to use figured dimensions on the drawing. Try to avoid as much as possible scaling. This scaling is very dangerous. Try to use the figures that they have presented on the plan. Much as they are not accurate, sometimes also architects are tired. He's been working on a drawing. He wanted it to be 3 meters, but the actual dimension there is showing 2 point. Then he tells you, no, it is 3. So it is up to you to check and see if the 3 matches the other dimensions, but go for figured dimensions, what they have written down. It is sometimes necessary to build up overall dimensions from a series of figured dimensions in the West. I did this before. I began by adding 3 meters. We normally use the font slightly smaller. You make as rough work, like you do rough work in an exam. So you make them tiny on top, but you tell us at the top, you will say, right, foundation. And then how you build it, we shall see. In exams, by the way, we normally award marks for those build up. Even if you got it wrong in the answer, the examiner, myself, I'll give marks. I may probably, you never know, you forgot or by rush, then I look at the build up and say, no, I think he or she deserves marks. Numbering and titles of dimension sheets, this is the key. Sheets, every sheet, every dimension paper sheet should be suitably headed with the title and the section of the job at the top and numbered at the bottom. We number at the bottom, but we give a title at the top. We shall see. Order of taking off. I said, this is the order. Whether you are in Europe or where, this is the order. Now, if any of these beginning from Roman 1 is not there, that means the first item to appear or the first item you are working on, say it is the roof. The roof is item number 7. That means you will go to the roof. But the order, we begin with site clearance, then we go to foundations up to and including damp-proof courses. We go to brickwork and face work. We go to block work. We go to floors. We go to roofs. We go to finishings. We go to windows, doors, fittings, up to external works. External works, that means after you are done with the project, then you begin to work on the compound, grassing, then paths and so forth. Okay. Next, I'll take you to the descriptions. General requirements. Descriptions must abide with or cover all matters that are detailed in the SMM, including all information the estimator will require to build up a realistic price. So always give the details. That's what this writing means. Then the order of wording, the first few words of a description should clearly indicate the nature of item being described. If it is a foundation, the first few lines should tell us that. Then the number of units. In some cases, it is necessary to give the number of units involved in a superficial or linear item for the estimator to determine the average area or length of unit being priced. So, for example, here we have 20 by 3 meter wall. The wall is built in standard size approved burnt clay bricks in cement mortar 1 to 4, and the thickness of the wall is 230 millimeters. But this happens, for example, if you are working on a structure which has columns in between. So assuming these walls are put between columns, say there are 4 columns, the first wall you measured was 20, length and height is 3 meters to the slab level. Then you don't have to total, to write and total. Just write the 20 by 3 and then times it by 4. So that means you are covered. Now, I will go to the query sheet, and I will have to end here with the query sheet. When taking off, any doubt or queries will be forwarded to the architect on query sheets, normally divided down the center to accommodate the queries. Queries means what is not clear. While you were taking off, you discovered that there were certain things that are not clear. So you write them in the query. You say, column pad number, you say wall length between grid 5 and 4, not clear. So when this goes to the architect will respond to you in the answer column. So during examinations, the candidate will have to decide the queries as they arise, but it will often be desirable for you to indicate briefly in the West why you have adopted a certain course of action. Of course, at least not with me. I can't give you a question which will require you to bring up this, but this is for official use when you are in the field. I would love to end here, and probably I will give you a chance to ask 1 or 2 questions on what we've answered, and then I'll close. I thank you. Are you there now?
Yes, we are there, sir.
Yes.
We are there.
Yes.
We are there.
Now, can I receive or get 1 or 2 questions and then I close? If there is any, you tell me your name and then the question.
Is it me, sir?
Yes. Yes, can you please get near your gadget? You are?
Mwongo Ibrahim speaking.
Okay, Ibrahim.
I request you to repeat on deduction is, what part for deduction is? Deduction is.
What was not clear?
You explain more. Explain. I didn't get it, sir.
Yes, Mwongo Ibrahim, I want to understand, what didn't you get well? Because if you look at that presentation, it was very clear. I said that normally when we are taking off, if we are taking off, say, walls, what we do, sorry, let me first mute you. Okay. Now, I said, if you are handling deductions of an item, for example, if it is a wall and the structure is big, you are not going to keep measuring unit per unit. Say you enter in the dimensions paper that, okay, from here, where is the door is in the next 3 meters. Let me first enter the 3 meters. No. What we do, like I will show you, we use our mathematics knowledge. You will take the circumference or the length of the entire total wall. And then you will know that the wall, say, when I measured, it went to 100 meters. But then on that very wall, there are about 5 doors. Each of these doors is about 0.9 by 2.4. So you get the total area of the wall, and then you begin to deduct. And we write below, deduct the number of doors. You enter the first door, its area, times how many are there. If there is a window, you do the same. So the one who's handling the final presentation, I will show you how we do the abstract if time allows. We'll get all those totals, and then you will get the actual walling. But for you, the taker off, I said you measure all the items at a go, and then you indicate the adjustments for those block works. And you describe, this time you don't describe it as a window. You will just say deduct ditto or deduct the original walling that you had calculated earlier. That is what we do in this nature of work. I hope I've responded to you, Ibrahim.
Okay, sir. Thank you. I get you now.
Okay, any other question?
Yes, sir.
Thank you very much, sir.
Yeah. May I get your name?
I'm Hilary Kanzira.
Hilary.
Yes. I'm requesting if you can share with us the notes that you have been using, because we don't have any reference like after we pass through the notes, and we really capture the information very well. Otherwise, thank you very much for the lecture.
Welcome. Don't worry. Don't worry. I'm going to share with you this information. I was trying to edit, because what I do every year, I edit my notes. There are things that were in the other notes that will not appear in your notes, but I'll give you definitely the notes. But I request you first to understand this. This is better because the notes are detailed a bit. They will drag you far. You understand, Mokulu Hilary? And thank you for appreciating. So I will give you the notes definitely. Now, what I wanted not to avoid giving you portions, like I've handled the chapter 1 to chapter 3. Next time I come, I will handle chapter 4, and then I will be able to give you the first set of notes.
Okay.
Yes.
Okay, sir.
Welcome.
This is Solomon.
Who?
Solomon Bajira.
Ajira who?
Bajira Solomon.
Mbazira.
Yes.
Philemon.
Solomon. Bajira Solomon.
Okay.
I was requesting for more clarity concerning preamble clauses.
The what?
I was requesting for more clarity concerning preamble clauses.
I'm not getting the last word.
The preamble clauses, I was requesting for more clarity.
Yes, where exactly?
When they are being looked at the head of each work section.
Now, I said, I want actually to encourage all of you. I said that these preamble clauses are able clauses we insert at the head of each work section. Like you've seen in the order of presentation here, the preamble clause will appear, say, for foundation. Now the clause will say, foundation in oversight concrete should be done by a specialized contractor, if possible, ABCD. So that is what we call a preamble. The preamble is a guidance, and I said it should be brought to the attention of the estimator as they affect the rates. The rates should be done by the estimator. The estimator, that one is another level we shall do in year 4. But the estimator, every estimator, even if it is you always read the preamble to understand. They may say, this is supposed to be done by the Chinese, this nature of work. So that it guides you, the rates by the Chinese will differ from the rates by the Ugandan expatriate. Hope I'm clear.
Thank you, sir.
Welcome.
Good morning.
How are you? Who's this?
Thank you very much, sir, for that. I'm fine. Thank you, sir. I'm a bit about Mary.
Mary who?
So I would like you to kindly clarify about the reason as why specification is not a contract document. Birabwa.
You said Mary Birabwa. Did you say Mary Birabwa?
Hello.
Yes, please.
Yes, sir.
You said you are Mary Birabwa.
Yes, I said Mary Birabwa.
Okay. So
I'm kindly. Yes, sir. So I'm kindly requesting you. Sir, hello.
Yes, I'm listening.
I'm kindly requesting you to clarify about the reason as to why specification is not a contract document.
Oh. No, I hope you didn't get me well. It is a contract document, but I said when it comes in building contracts, I want you to quote me well. I said in building contracts, but when it is about civil engineering contracts, it must be. So these are two works. Because the building contracts, usually these specifications will be provided by the architect in the drawings themselves. So we normally don't have to waste time for specifications. That's why I said in building contracts, specification is not a contract document.
Good morning, sir.
Okay, thank you.
How are you?
Thank you very much, sir.
Welcome. Yes. Yes, may I know your name?
This is
Nantaba. Let me get Nantaba who? Nantaba Monica. Okay. Yes.
About when we were talking about measurement figures.
Yes.
There was some market
Sorry, come again.
So like when we were talking about measurements of irregular figures,
the vertical column.
Yeah, it was there were talking about of the triangle and the circle, finding that, but then there were other things in the first column that they didn't talk about.
In the first column, I talked about them. Look, for example, area of a triangle. Okay? In the area of triangle, the length, what is the formula for a triangle? Yes? Half times base times height. So I said, if you look at my right hand corner, I said the base is 4 meters and the height is 3 meters. So I entered them in the second column. Now the half is the one I put in column 1. Yes, so we entered the other multiplying factor in column 1. That's why even when you look at the circle, when we say the pi r squared, the pi is put in the other column. Yes. Have you seen it?
Thank you very much.
Yes.
Name? Figures.
You are
the measurement of regular figures. Kayipona Muhire. On the measurement of regular figures, where you put the volume cylinder, I need more clarification on the how you presented the figures in the timing column.
In the what?
In the timing column.
Time using column.
Yes, sir.
How I did what?
I need more clarification, more explanation on how you presented the a half and the 2 pies in the pie, because I see 22 over 74.
Okay. Now the problem is you have the woman that you bring. You have the woman there is watching.
Okay. Are you still there now?
Yes, sir.
Yeah, now what I said, you wanted to ask the circumference. Are you talking about the circumference? Right?
I'm talking about the volume of the cylinder.
Yes, what is the formula of the volume of a cylinder? The formula, let's get it from there.
Pi r squared h.
Yes, pi r squared h. So the 0.5, this cylinder had 1 meter diameter. The radius is half a diameter, and half of 1 meter is 0.5 meters. So 0.5, the squaring is entered twice, 0.5, 0.5, that is already r squared. And it has a height of 3 meters. And that's why I enter 3.00. So the pi is put the other side in the first column. Next.
Hello, sir. Hello.
Yes, I'm listening.
This is Semata Isaac. Yes, just inquiring about the units of all these presentation, like the work. Are there standard units we are using for all this work, like meters? Like your work should be presented in meters throughout, or you can use any units as long as you are consistent?
You must have come late, because I explained that, and I said that with those feet you use at the site, I made that statement that we use metric, and the minimum unit is a millimeter. But when we are entering, we use meters. We use meters.
Oh.
Yes, I made that statement. You must have entered late.
Okay,
next.
Sir, thank you very much.
Welcome.
Good morning, sir.
Good evening. How are you?
Thank you. My name is Amaithe, and I just have 2 things to say. Firstly, I'd like to appreciate you for the quality of the presentation.
Thank
The
you.
video and the audio were all efficient. Then the second thing is a suggestion. I'd like to suggest that maybe if we could schedule our lectures to be 2 hours long, because considering it is Zoom, that data consumption is very high.
And I think that's what I've done. What is the time now?
We're coming to 2 hours and about 47 minutes or 40 minutes.
And no, I didn't begin at exactly 9. We had the challenges. You asked those who were here. I was supposed to begin at 9, but I was in another meeting. Secondly, when I checked the meeting, I was already there. I had registered only 2 people. You asked the first guy, I don't remember his name. I called him and was wondering, where are these guys? Even when I said I'm beginning at 9:30, it was not until 10 minutes to 10 that we got a good number. But still, what I can say, all your request is in my favor, because I'm a busy being. Even if you want it 30 minutes, the better for me. But of course, you know, there are two characters here when we come to school. I will be doing you a disfavor if I don't give you all that you must learn here. If I just come and take only 30 minutes, remember, me, I will be paid full, but I will have done you a disfavor. But if it is the agreement of everybody, I can use 30 minutes and I always end.
I said 30, so I was suggesting just 2 hours.
No, but this is it. You said it is just coming into midday. Now you get 9:50, deduct the time, and actually I ended before. And I've only given you time for questions. Maybe you don't want questions. I go off. Is it the consensus that every time I present and run away?
No, sir, it's okay.
No, because this time you are hearing, actually I've spent now close to 30 minutes or 40 on questions. So if you want me to end and say bye-bye, I can always do that. If it is the agreement, just discuss that. I can always start and then run away. Yes?
Please, sir, don't take it that way. Take it easy.
No, I normally, my character when I'm doing lectures, I'm serving. I don't want to produce half-baked engineers and then we complain in the field. But I'm saying that what I'm doing is for benefit of us all.
Okay.
Okay.
Fine, sir. You can go with that. Thank you.
Welcome.
Excuse me.
Yes.
I was requesting, it's still Monica Nant. I was requesting that, okay, if they could send us kind of like those kind of those tables that we've done, and not really a assignment, but like this help like to guide us so that we keep practicing. Like, yeah,
like a what? Now let me respond to you. Those documents, like the ones I do myself, we swear an oath. You don't just display, for example, documents of Bank of Uganda or where the projects I'm handling. My client wouldn't be happy. What I can only say, I said I will explain, and I've requested you to look for some of those documents. Those who are near me can easily get access to them because that is my daily work. But giving out this legal document, a client wouldn't be happy with it. Yeah.
Okay, so are there no like books or something that has something like that so that you can send us and we just keep referring to them?
No, nobody can put, you know these documents, these contract documents, you'll get a booklet with over 1,000 pages. Now, who can write a book and then include an attachment of 1,000 pages? Nobody. Just like specifications alone, it will carry several, it is a book on its own. What I can advise you, you can look for a consulting engineer who's dealing in this. It is unfortunate that we are doing this when you are in a holiday, but those I normally lecture. The first lecture I do is to bring it to their attention. I carry these booklets and they are able to appreciate. But I'm not saying that we shall not. Once we get time together, you remind me. And those who are nearby where I am, probably we can find time and we do that together. I will show you, I will definitely show you those documents. So I want to thank you. I pray that we meet again next Wednesday. We keep time prompt. Our lecture goes about 2 hours. Yes?
Yes, sir.
I was inquiring.
That what? I think that is on my question.
Excuse me, sir.
Yes. Lastly.
This is Tumeva Nelson. I was kind of requesting maybe you can lead us in the closing prayer and end the lecture. I appreciate you presented well. Thank you.
Welcome. Let's pray. Heavenly Father, we want to appreciate you for the gift of life. It is my joy when I see human beings able to discuss and share from wherever they are. Heavenly Father, we are not yet given up. We still believe you are with us to the end, even amidst this coronavirus. Father, we just witnessed, oh my God, that amidst all these challenges, you are alive. According to Job 19 verse 25, he says, my Redeemer and my Vindicator is alive. Father, we want to thank you for even the news that we are hearing, the healings in today's paper, the many that are healed. We believe very soon this lockdown will be lifted and then we shall be able to get together. I want to pray a special blessing upon all my viewers today. Continue guarding them, keep them safe until we meet. Thank you for the class and even journey masses as we part. We continue to pray for provisions from above. Protect each one of us. Through Jesus Christ our Lord, we pray. It has been a pleasure with you guys. Thank you. God bless you.
Amen. Thank you too. God bless you.
Amen. Amen.
Amen.
Amen. Other sentences are not banja.
God bless you too.
Bless banja tumbanya.
Gendo kole.
Banja tuksing.
Koze kole zawe ga irgaza na